Today we're going to be talking about adding and subtracting fractions. You should have some experience with this, but we're also going to throw in positives and negatives. So our integer rules that we learned back in chapter 1 still apply. So you need note 7. So let's label this as note 7 and get ready to rock and roll. So when you're adding and subtracting fractions, you have to have common denominators. If the fractions already have a common denominator, you keep the denominator and add or subtract the numerators. If you need to simplify further, you'll go ahead and do that. So if we take a look at this first problem A, we already have common denominators, so we'll add the numerators. 3 plus 1 is 4. Since the denominator is the same, we keep it and bring it over. On B, we have 7/6 minus 5/6. Same denominator already, so we'll subtract the numerator. 7 minus 5 is 2, and keep the denominator. But here I simplify by 2, and so our final answer will be 1/3. Now, if you don't have common denominators to start with, you're going to have to get it so that both fractions have a common denominator. So we first have to find the LCM and use the LCM to find an equivalent fraction for each of the two addends, and then simplify that expression with common denominators, and then simplify further. So let's take a look at this first example. If you don't remember how to find an LCM, we're going to go over that right now. So we have -7/3 plus 3/4. I notice I have unlike denominators, and I need to figure out what the LCM is. So to find the LCM, we're going to list each denominator, and we're going to start listing the multiples. So 3, 6, 9, 12, 15. And for 4, 4, 8, 12, 16, 20. And you're going to find the lowest number on both lists. And I see that that's 12. So that's going to be our LCM. So now we have to use the LCM to find an equivalent fraction for each of the addends. So we have -7/3 plus 3/4. And we know that we want each of these to have a denominator of 12. So we have to figure out, what do we have to multiply each fraction by to make that happen? So what times 3 is going to get us 12? Well, it's 4, so we're going to multiply 3 times 4. But if I multiply the denominator, I also have to multiply the numerator, because multiplying by 4/4 is really just multiplying by 1, and anything times 1 is itself. So then -7 times 4 is -28. Then for the second fraction, what would we have to multiply by? 3, exactly, but really 3/3, because 3/3 is 1. 3 times 3 is 9. And now we're ready to actually add, because we have the common denominators here. So we have -28 and +9, different signs, subtract, keep the sign of the higher number, and then we're going to keep the denominator. This is an improper fraction, so we have to convert it back to a mixed number. 12 goes into 19 how many times? Once, with how much left over? 7/12. But remember, we have a negative, so here is our final answer, -1 and 7/12. You try number 2. First, figure out what the LCM is. Pause the video and work it out. Let's take a look at number 3. So we have 2/7 plus -4/6. Well, first, I know that this is a 1, and a positive times a negative is a negative. I also see here that I noticed something about 4/6. I can simplify it before I get working. So 2 goes into 4 twice and into 6 3 times. So the denominators I'm dealing with right now are 7 and 3. Well, what's the LCM between 7 and 3? If you don't know, just start listing the factors again. 3, 6, 9, 12, 15. And for 7, 7, 14, 21, 28. Well, I don't see anything in common on this list, so I need to keep going. So after 15, we have 18, 21. Oh, 21 popped up again, so that's my LCM. So what I'm going to have to multiply by, I have to multiply 2/7 times what to get a denominator of 21? By 3. right? 7 times 3 is 21. So I'm also going to multiply the numerator by 3. And 3 times 2 is 6. Over here, we need to multiply 2/3 by what? That's right, 7/7. So 2 times 7 is 14, and 3 times 7 is 21. Now that we have common denominators, we're ready to subtract. The 6 is positive, the 14 is negative, different signs. Subtract and keep the sign of the higher number. So we're going to subtract and keep the sign of the higher number. Keep our denominator. Since this is a proper fraction, there's nothing to simplify. And we're done. You try number 4. Let's jump over to the back side here. So we've worked with common denominators, uncommon denominators with proper and improper fractions. And now let's talk about working with mixed numbers. So there's 2 ways that we can work with mixed numbers when we're adding and subtracting. The first way is the way I've assumed that you've seen. Turn the mixed numbers into improper fractions and then proceed like we were just doing by getting common denominators. So we're going to work these first 2 problems in both of those ways, or that first way. So we've already seen that this person has already converted our double negative into our positive and has already converted our mixed numbers to improper fractions. So now we just need to do what we did on the other side. So we need to look at what the common denominator would be between 4 and 8. Remember, list them out if you don't know. Did you figure it out? Yep, it's 8. So we have to multiply 9/4 times 2 seconds. Do we have to multiply 27/8 by anything? No, we don't, because it already has a denominator of 8. So here we have our 18/8 plus 27/8. They're the same sign. So we're going to add 18 plus 27, 35. Keep the denominator. Oops, not 35, 45. Sorry about that. And now convert it to an improper fraction. How many times does 8 go into 45? Well, 5 times 8 is 45. Nope, 5 times 8 is 40. That's 5 away from 45, and we keep the denominator. Now, another way you could do this, option 2, you'll see right here. You can add or subtract the whole numbers first. So let's start with that part. 2 1/4. We know this is going to be plus 3 3/8. Well, my whole numbers are 2 and 3. And so 2 plus 3, that's 5. Then it says, then get common denominators. Let me pick a better color here. Then get common denominators and combine the fractions and follow the steps listed in example 2, which was on the front side. So now we're talking about the fraction pieces, the 1/4 and the 3/8. We already know from before that the LCM was 8. So here I need to multiply by 2 seconds. So 2 times 1 is 2. 4 times 2 is 8. And then we're going to add the 3/8, which gets us 5/8. And now, if we combine our whole number with our fraction, we end up at 5 and 5/8, which is what we got before. Let's try this one more time, doing mixed fractions both ways. So option 1 says, okay, convert to improper fractions. So 3 times 3 is 9, plus 2 is 11/3. My double sign becomes a negative. 1 times 7 is 7, plus 5 is 12. We're ready to get common denominators, which we already know to be 21 from the other side. So we have 77/21. minus 36/21. We'll subtract our numerators, keep our denominator, and convert our improper fraction back to a mixed number. So we have 1 and 20/21. Now for option 2, it's a little bit trickier when we have different signs. Remember on problem 1, we had the same sign. But we can still do it. So we have 3 2/3 minus 1 5/7. So first we're going to add or subtract the whole numbers. So 3 minus 1 is 2. Then we're going to deal with the fraction bits. So we have 2/3 minus 5/7. Again, we'll get those common denominators. And we'll simplify. So 7 times 2 is 14. 7 times 3 is 21. 5 times 3 is 15. 7 minus 3 is 21. 14 minus 15 is negative 1/21. So now what we have here is 2 plus negative 1/21. Well, that's not much of an answer, is it? So this is really saying 2 minus 1/21, 2 wholes minus 1/21. So if I'm taking 2 and I'm subtracting a bit, I know that my whole number has to go down to 1. But then how many 21sts make a whole? Well, 21 do. Well, how many do we have right now? We only have 1. So the amount that's missing is 20 of them out of 21. And then we end up back where we started. Now it's your turn. Choose one of the options and try A and B. Pause the video. Let's do C together. 4/1. I might choose option 1 or option 2 here. Doesn't matter. So let's go with option 1. We have 4/1 minus 1 times 9 is 9, plus 7 is 16. So we have 16/9. We'll multiply here by 9/9 to get 36/9 minus 16/9, which is 20/9. And when we convert it to a mixed number, we get 2 2/9. That was option 1. Sometimes it's just much more efficient to try option 1, and other times it's much more efficient to try option 2. Take a look at D with me. I noticed that I have this double sign, so -8 minus 6/7. Same sign, add and keep the sign, right? So I'm going to just add them. That's it. If I were to add the whole numbers would be -8, and there's no whole number on the -6/7, so that's -8 plus 0. And if I were going to add the fraction bits, the 8 doesn't have a fraction. And then I have -6/7, so that's -6/7. It doesn't make sense to first put -8/1, multiply it by 7, because then we're going to be larger at -56, and it goes on from there. So you really want to be judicious about what's more efficient. Go ahead and try E and F and see what works for you the best. Great job.